Okay, so I'm here to present about the, I've never really given this an interesting title, the GIS-based dissolve, yeah, you can read that. But long story short, basically it's to deal with some of this real kind of back-end sort of mapping that we do as part of our flood forecasting here. So it's myself and Maritza here at ESoWC and Markus, who will present after me, who's actually done the work. So just to give an overview, so ESoWC is obviously known for its weather forecasting, but for hydrology, for river forecasting, that's obviously very useful for that purpose. Obviously, if you put all that rainfall into a river model, you can see how potentially it may flood. So on behalf of the European Commission, the Joint Research Centre, ESoWC are the computational centre of the European Flood Awareness System, and also the global one, but for now we just focus on the Europe one. So basically what happens is we take ESoWC's weather forecast, put it into a river model, and see if there's going to be flooding in Europe, and some of the other centres here at the bottom will issue those warnings. So this is just basically a very quick summary of that. So on the far left-hand side is basically weather models that are input into a river model, which produces river discharge forecast twice a day at 00 and 1200, and then they're used to highlight on the bottom right where may flood, and from that we can issue flood notifications to partners. Which is done by our dissemination centres who are in Sweden and Slovakia and the Netherlands. So in terms of where this challenge was coming from, it all sounds very trivial, but it's not. This map here shows in the shaded colours, so the pink, blue and the yellow, our current EFAS partners. So any flood that happens within those shaded areas, the institutions, so the civil protection agencies or the environment agencies there will receive a flood notification from us. Now, this is just simply what's shown on the map if you go on the EFAS website. But the issue is if we want to add a new partner. So you can see, for example, that Denmark are unshaded, they're currently not a partner. And just we'll give a quick example, but Galicia on the top left of Spain aren't a partner. So entire countries aren't partners, basically. And this can be a bit of a pain. So one of my day jobs is if a new partner comes along and says, we'd love to join, I need to edit that. It's a shapefile in the background. I need to edit that to kind of fill in the area. So the idea being, if Galicia decided to join, I would need to make this area become pink, which sounds really, really simple, and it really, really isn't. It sounds stupid. And because at the moment our workflow is to use QGIS. So in this example here, the purple would represent the new area that needs to be filled in. And you would just think, simple, take your existing shapefile in the pink, the new one in the purple, and just dissolve it together using that tool. But what usually happens is it doesn't really work. You end up with like gaps all along the borders because the boundaries don't exactly match, doesn't do well with overlaps. And QGIS is pretty bad at handling vector data if it's got geometric errors in it. Things like points overlapping or going around on each other. There are tools to fix it, but most of the time we end up actually having to fix them manually. You know, I've had to go through like the entire Spain-Portugal border and manually correct it, and then it just reintroduces the errors again. So we basically needed a better tool. And then a sort of secondary problem that we have is that when we issue a notification, we actually need to find all the partners who lie within the same basins, not just at that point. So basically this is meant to give a quick schematic. Apologies, it's a bit basic. I drew this up quickly for Markus at about midnight just before I was going on holiday, so it's a wee bit basic. But the idea is that the blue is a river basin, like the most angular one in the world, and these black dots represent our 5 kilometre model cells, so they would be pixels if you like. So if we were to generate a flood notification here, we would need to highlight this blue area and then extract all the orange partners who lie within it. But because that process is incredibly slow, we need to pre-generate it for each black point offline so that then our operational system can run a bit quicker. But that procedure to do that is very slow. So another challenge we posed to Markus was to see if he could create a plugin for that. So in terms of the solution that was proposed, basically we need to find firstly a quick way to remove the geometric errors in our input shapefiles, basically have a new dissolve tool that actually works, and then you go into this river basin lookup procedure. So Markus will now talk about the tool that he has created. Okay, I'll do that.
Okay, I'll take over now. So can you see the first slide?
Yes.
Okay, so I'll immediately start. Also with the summary, this is essentially what Calum has just introduced or explained. So the different challenges. The first one is adding a new partner region to existing partner regions. And the second task was to update the river basin database with partner region IDs, including any new IDs that have been added. So I decided to use GRASS GIS. Well, first because I'm a GRASS GIS developer, and second because the vector model of GRASS GIS is a purely topological, a true topological vector model that facilitates the correction of these geometrical errors. GRASS GIS is an open source GIS, has been around since 1984 and is portable across all known current platforms. And yeah, it's linkable to all sorts of other processing tools, including, for example, QGIS. Just a quick intro, a quick demonstration of the timeline, GIS timeline, at what time GIS tools have been created and developed and which ones are still around. So GRASS GIS and the Crutch library are still around and they are amongst the oldest ones in the open source world. This open source geographic world is OSGeo mostly, and it's a little universe, and you are happy to try out all the other tools, not only QGIS, but there are many other very interesting tools and software packages. So GRASS GIS was also a funding member of the Open Source Geospatial Foundation, just to show you a little sketch of the organization. It's not only about software, it's also about data, education, and of course the community of all people involved somehow in open source GIS software. You can also try it out live if you want to check out new features, if they are suitable for your company or your purpose, research, whatever. A quick introduction why I decided, or why I think that GRASS GIS is suitable for this particular task. The main advantage is its true vector topological processing engine that yeah, not only facilitates the correction of these errors, they are actually usually corrected automatically upon import. It also provides a nice framework for example vector network analysis. The other parts are probably not really relevant. I'm just listing them for completeness, that GRASS GIS is a general purpose GIS toolset that can not only do standard raster and vector processing, but also, for example, imagery processing and the time series processing. GRASS GIS is, for example, in contrast to QGIS, not a single application, but a set of about 400 something different applications that can be used independently and sequentially and combined in any way. And this makes it a nice GIS processing engine that can be used as the backend in many different applications. There are a few particularities about the GRASS GIS concept, just to mention a computational region for raster processing, which is not always considered by other software, but which is a very powerful tool to steer the processing of raster data. So the main concepts of GRASS GIS are the computational region, the raster geometry, and the display geometry. Now this is more important for the current task of the summer of weather code, the vector geometry. It's not consisting of independent polygons. Instead, like in real world, it's consisting of boundaries that constitute an area. So sticking to the example of, for example, Portugal, we have different boundaries, the coastline and the common border with Spain. And the common border with Spain together with the coastline constitute the area of Portugal. And again, for Spain, the common border of Portugal, the coastlines, and the common border with France constitute the area of Spain. That means that inherently these overlaps and gaps that Calum has just mentioned in the introduction simply cannot arise. It is not possible, or it's very difficult to actually get such artifacts in this truly topological vector model. So this is just an example what happens if you do geometry simplification of separate polygons. Initially, the polygons were matching each other nicely, and after geometry simplification, if you don't take care, you get these overlaps and gaps. This cannot happen if you use a truly topological vector model. Another particularity of GRASS is that there's no reprojection on the fly. You can reproject, but you have to take care about the settings because too many things can go wrong if you reproject on the fly. And yeah, the user lists on various GIS software forums are full of problems about reprojection errors. And most of them can actually be avoided with GRASS GIS. So in summary for GRASS GIS, it's quite old, and it has from the beginning designed as a multi-user network GIS environment that incidentally makes it perfectly usable for, example, cloud computing or high-performance computing nowadays. All data need to be in the same spatial reference system, and data with different spatial reference systems need to be reprojected into one common spatial reference system. Now, this sounds maybe all a little bit complicated, but the big advantage is that all these tools needed to perform these tasks can be automated. To use these GRASS tools, we need a GRASS session, which is essentially a set of environment variables that need to be established, and after that, all the GRASS tools are available. This is also the concept how QGIS plugins are using the GRASS tools. This is just an example how to set up a GRASS session on the command line and then continue processing on the command line if you do cloud computing or something like this. And of course, there's also a GUI, graphical user interface, which is mostly a wrapper around the command line tools. The GUI facilitates also the development of scripts, workflows, more complicated or more elaborate workflows that can after that be automated. This is essentially the way how I develop the tools for this summer of weather code challenge. These scripted workflows have several advantages. We have implied documentation. We can fine-tune the parameters, for example, for time series processing, and we can also process spatial chunks in parallel if this is needed, and all this guarantees higher repeatability. So GRASS can be started without starting a particular application or executable. And well, this is also a reason why the development of QGIS tools, for example, is fairly easy. I'm now coming to the challenge, to the first part, the dissolve tool, adding a new partner region as introduced by Calum. Again, this is the same example with adding Galicia to the partner regions or to the dissemination centers. And as you can see here, Galicia is not matching exactly the existing partner regions. In this case, it's overlapping, and that needs to be dissolved. And the result you see on the right, and the first tool is doing this process automatically. All you have to provide is the input data and then hit run and wait for the output data to be generated. And the tool has been designed such that no manual cleaning is necessary. So the partner regions need to be dissolved. The input data consists of the partner regions, the existing partner regions that are already dissolved by dissemination center, and the new partner region that has been assigned to a dissemination center, and these need to be combined and dissolved. Output will be the updated partner regions, again dissolved by dissemination center, and the new partner region that has been cleaned of geometrical errors. The challenge here is that there are actually no requirements for any new partner regions. Any spatial reference system is allowed. That means reprojection is needed, which means that errors will be introduced or can be introduced. Also, any data source for any new partner region definition is allowed. There are absolutely no restrictions as far as I know. That obviously means if you pick the region polygon from one data set and compare it to a completely different data set, we have different levels of detail, and usually there's no exact match with the existing partner regions. And these challenges needed to be solved in an automated way, such that this lengthy automated cleaning is no longer necessary. For preparation, we first needed to clean the existing partner regions, which was a little bit of manual work because so many errors were already present in the input, but we have done this as part of the challenge. And yeah, so now we have actually clean input data, which makes it much easier to add a new partner region. And yeah, here again a short illustration on how it looked before and what it should look now. The clean version is topological clean, no more geometrical inconsistencies in the existing partner region. This is the fictional example of adding Galicia. So what we want to get is no matter if the polygons, input polygons overlap or have small gaps, we want a nice seamless result where everything is combined and dissolved according to the dissemination. This is Galicia is a purely fictional example. It has not been added yet to the partner regions. I have implemented it as a GRASS GIS add-on that can be run on the command line. It can also be run within GRASS GIS through a graphical user interface, and it can also be run through QGIS as a QGIS plugin. The second task was to update basins with the river basin lookup procedure that Calum has also quickly presented. So we have an attribute for each basin that holds a comma-separated list of all the IDs of all partner regions that somehow intersect with that point. So also an attribute that again holds all the IDs of all the partner regions that intersect with the particular river basin of this grid plot. And yeah, so we develop tools that also do the automated updating. They are not as fast as I would like it to be, but at least they require no user intervention. So it's completely automated. This is again the river basin lookup procedure that Calum has already presented to show what it should look like. So in this example, all grid points falling into that blue basin should have the values 1, 4, and 101, which are the IDs of the red partner regions intersecting with that particular basin. So the implementation was first as GRASS GIS add-ons. They are principally command line tools. A GUI for these add-ons is automatically generated by the GRASS GIS graphical user interface, and additionally we provided QGIS plugins that are simple wrappers for these GRASS GIS add-ons. So the QGIS plugins should feel like any standard QGIS plugin, and because There are 3 different possibilities that all make use of the same tools. The user has maximum flexibility on how to use these tools. If it needs to be automated, or if you would rather have it in GUI.js to see the results more or less immediately when the processing is done. And yeah, so in the end, this is again what it looks like in the web interface of the flood forecasting, flood analysis system. These shaded areas need to be updated, and they should look as clean as possible, and that should be processed, should be done automatically now with the 3 new tools that we provided. So, do you have any questions?
So, any question here?
Is part of Russia a partner?
Okay. So
this is a question that's directed. This is a question directed to Calum.
Yes, only part of Russia. The reason is that the hydrological model we run only goes that far eastwards. That's just the setup that the GRC has, and I deliberately cut the shapefile to be accurate to where the model is testing. Naturally, the Russians would want us to go a bit further eastward, which that's the reason why.
Thank you. Any more questions? I guess one of the questions is how easy it is to integrate this one into this. I don't know if Markus or Calum wants.
I can try and answer that. So the reason why I was very keen to have it put as a QGIS plugin is because that's what I use day to day. So in terms of GRASS GIS, I'm very new to it all. So the fact that Markus has written this wrapper to put it into QGIS means that we can bring it into our daily update procedures. So it's actually quite simple. Or else we just simply run it as a plugin, gives us the data in the format we